Hello guys, welcome to another video in the Team NetShot channel, and in today's video we're going to be talking about the Inmap tool. So Inmap is a network tool that is used by network administrators and penetration testers, ethical hackers, and it's actually been around since 1997, which is quite an old tool, but an amazing tool that is updated, and it has a lot of functionality, which makes it one of the most important tools that you should know. Alright, so let's get started. First, what is Nmap? Well, Nmap stands for Network Mapper. It's a free port scanner created by Führer and distributed by insecure.org. It's designed to detect open ports, identify host services, and obtain operating system information from a remote computer. Nmap now is one of the core tools used by network administrator because auditing network Nmap's results provide insight into the security of a network, which is you scanning a remote target computer. It gives you information about what the ports are open on that computer with the services that it's running, and it's available on Windows, Mac OS X, and Linux. So no matter what operating system you're using, Nmap is available for you and ready to use. Alright, so Inmap can perform a lot of type of scanning, which is mainly a scanning tool, and it can perform a lot of scanning. So the types of scan that Inmap can perform is the sweep scan, which eventually just Inmap sends a series of ICMP ping to find host. So it's not scanning ports for open services or anything. It just determines, you give it, for example, an IP address or a host name, and it determines whether that host is up and running or not. The second one is trace scan. Uses tools like traceroute or traceRT. Traceroute if you are using Inmap on Windows, and traceRT, traceroute is if you're using Inmap on Linux. So let me, yes, red. So traceroute is if you're using Inmap for Linux, and traceRT if you're using Inmap on Windows. Alright, so to map the network, what does that mean? For example, it scans. While it's scanning the host, it gives you the IP address of routes that the packet took from your computer to the target's computer. Okay, so now it's also a port scanning, which we're mainly going to be talking about in this tutorial. So it checks for the open TCP or UDP ports on the target's computer, and it gives you result determining which ports are open, which one are closed, and which one are filtered. We're going to be talking all about this in this video and the upcoming videos as well. It's also fingerprinting. So for example, it's using mechanism which determines the operating system that the target is running, and it's also doing version scanning. For example, if you do version scanning, then it's going to be doing the open port, the port scanning, but it also going to be, for example, it finds an open port like 80, it's going to do version scanning to determine what version for example, the server, the web server is running. It can also be used as a vulnerability scanning to scan for vulnerabilities in the services that the target machine is running. Okay, so first let's get started. But since we're going to be talking about using Inmap as a port scanning, let's first understand what port is. So a port is a virtual point where network connections start and end. And ports are software based and managed by a computer's operating system. Each port is associated with a specific processor or service. Ports allow computers to easily differentiate between different kinds of traffic. Emails go at different port than web pages, for instance, even though both reaches a computer over the same internet connection. So computer, for example, we have a computer here, and it has a lot of ports. And we have a server. It's going to connect to a lot of servers. For example, you're connecting to obtaining the for example, Google web page, and you emailing someone using an email, for example, and you have SSH'd into a remote server. So eventually you have only one IP address. So how does, for example, when it sends a packet, for example Google, and when the response can come back, how does the computer determines whether that response is made for this Google or for the SSH? So this is where ports comes into place. So for example, SSH run on port 22, and the server running is on port 80. So when the response come back, it's come back as an 80. Now it's going to be redirected to your port, and that's how the computer can manage to communicate with multiple services at one time using one IP address. Alright, so port scan, port number is a 16-bit number, meaning we have 2 to the power 6, which we have 65,536 ports available to us in our machine. Alright, and these ports are divided into 3 ranges from 1 to 1023 are called well-known ports and reserved for common TCP IP applications. For example, the HTTP service is running on port 80. Those are the default ports, but it can also be changed. For example, on a server, it's not like the rule that HTTP always has to run on port 80. It's like the default ports for those services. HTTPS run as default on port 443, SSH on port 22, FTP on port 21, and those are in the range of 1 to 1024. So you can look at the rest of the ports that are available in this range by just googling it. Alright, so the second range stands from 1024 to 49,151 and are called the registered ports, and they are not designed for assigned or controlled, but can be registered to prevent duplication. Right, and the final range starts from 49,152 to the last port, and are called dynamic ports, and they are the free ports that are available for any TCP or UDP requests made by any application. They are available to support application traffic that has not been officially registered in the previous ranges. So you're, for example, testing an application on your server and you're afraid that you can collide using a port that's already been registered for a well-known application service. Then this range, you can choose any port from this range, and you are and those ranges, those ports are free to use. Okay, so for example, let's now talk example. So an example. So we have our machine. It's making a lot of connections with a lot of services. For example, as we see, it's connecting to this service via SSH. It's requesting the homepage of Google, and it's also transferring some files using FTP on port 21. Alright, so first, when it connects to the SSH, our computer chooses a random port. So when the response comes from this port, the SSH22, it knows to redirect it to the service that's running on this port on our machine. And the same goes for Google. For example, when the response comes back, it's gonna redirect it to the service that's running on this port on our machine, and the same goes for any other service like FTP. Alright, so when port scanning, when using Nmap as a port scanner, there are 3 basic scan types. There is the TCP Connect Scan, which is the one we're going to be talking about in this video. There is the SYN, which is also known as half open or stealth scan, which is toggled by the switch dash lowercase s uppercase s, and there is the UDP scan. So let's get started with the TCP Connect Scan. So to understand the TCP Connect Scan, which is you can use the TCP Connect Scan in Nmap by using the switch dash lowercase s uppercase t. So first, it's important to understand and to be comfortable with the TCP three-way handshake. So for example, here is our computer trying to request, for example, let's see, this is a Google web server. It's trying to request the homepage of Google. So before our client even sends the request to the server, there has to be a connection that is between our client machine and the server So first, our client sends a TCP packet with the SYN flag set. It's saying to the server that our machine is trying to synchronize with the server, and then the server sends a SYN-ACK, a TCP packet with the SYN-ACK flag set. SYN meaning that the server is also trying to synchronize, willing to synchronize with our client, and the ACK flag to indicate to our client that the server has actually received the previous packet, which is the SYN packet. And then finally, our client sends him back a TCP packet with the ACK flag to the server, indicating that it has received its previous packet, which is this one. Okay, so when this ends, when we have actually initiated a connection between our client and the server, then we can start transferring information between the client and the server. We can request the homepage of Google, and the server can reply back to us. So this is how Nmap actually does. So when you use the dash lowercase s uppercase t, you're indicating to Nmap that you are using the TCP Connect Scan when scanning your target. So the Nmap will send the SYN packet, a TCP SYN packet to the server, and when it receives a SYN-ACK, Nmap marks the port as being open and finishes the three-way handshake by sending a TCP packet with the ACK flag set. So that's how Nmap determines, that's how the SYN, actually the TCP Connect Scan works. So, but what happens, this is the scenario when actually the port is open. So what happens when we scanning a service but the port is closed? So now, when the port is closed, the target server will respond with a TCP packet with the RST, which is the reset flag set. So our Nmap, as always, it's gonna be start with the TCP packet with the SYN flag set. It's gonna send it to the server, and then if the port is closed, then the server has to respond with an RST TCP packet with the RST flag set. When Nmap receives such a TCP packet, then it marks the port as being closed. Okay, so, but there is another scenario, because if the server we are connecting to is protected by some kind of firewall, then the firewall might be configured to drop all the incoming packets except packets that are coming from trusted resources. For example, if this is an SSH server, a private one, then the firewall might be configured to drop all incoming connections except from a trusted IP address. Probably you have a a public IP address. It's not going to be changed. You're always going to be connected from that IP address. Then you can configure the firewall to drop any incoming connections except from that IP address. So the firewall simply, it's gonna of course, yeah. Nmap, it's gonna start the scan by first constructing a TCP packet with the SYN flag set. It's gonna send it. The firewall gonna intercept that packet and simply gonna drop it because it's not from the trusted IP address. Okay, and then it's not gonna send any response. So the Nmap, it's gonna wait for some time. It's gonna time out, and when it receives no response, it's gonna mark the port as being filtered. So those are the three states for ports when scanning using the TCP Connect Scan. There's the open port when the Nmap receives an SYN-ACK packet from the target machine. There is the closed port when it receives the RST packet from the server, and there is the filtered state when it didn't receive any response. Okay, so when performing the TCP Connect Scan with Nmap, there are three states for the port. There's the open state when it receives a SYN-ACK packet. There is the closed port when it receives the RST TCP packet, and there is filtered state when it receives no response. One important thing is that the TCP Connect Scan is the default scan when Nmap is used by a non-privileged user. So you are not the root user, you're not in the sudoers group then the default, if you didn't specify any type of scan for Nmap, then it's gonna default to the TCP Connect Scan if you are a non-privileged user. Alright, so now we're done with the slides. Let's now go and actually use Nmap. So if you're gonna install Nmap, if you're using in the distribution of Linux, you can use the package manager. For example, app, it's gonna be sudo, the command would be sudo apt-get install Nmap, and it's gonna install it for you. If you're using Windows, you can navigate to the Inmap.org website and download the zip file from there, and you can have an executable Nmap file. Alright, so let's use the Nmap-help to see some, and you can see we have a lot of options because Nmap is a really powerful tool. So we have the target specification. Probably I'll be discussing this in the last video in this series, because it's not really that big of a deal. It's easy to understand. We have the host discovery. I'm gonna be doing this in another video. And we have the scan techniques. We have the SYN scan, the TCP Connect Scan, and we have the AX scan and the UDP scans. We're gonna be using in this the TCP Connect Scan, but I'll be also talking about some of the switches that can be used with the TCP Connect Scan and any other TCP and any other scan. Alright, so Nmap actually has given us a website that we can scan, because scanning can be sometimes illegal. You can't scan, I don't know, but Nmap has given us this website called scanme.org, which we can scan free without breaking in a law or anything. Alright, so the simplest Nmap command would be Nmap. So we're using the st tell Nmap that we are using the TCP Connect Scan to scan our target, and then you specify our target. It can be a host name, a CIDR notation if you're scanning a network. It could be an IP address. Alright, so in our case, we're just going to type scanme.nmap. You can also scan your home network or your own machine. It's up to you. So .org, and then that's it. Just hit enter and wait for the scan to complete. If you want to see the percentage of the scan, you can just hit enter or any other key. Now it's okay. Just wait for it to complete. So if you didn't specify any port, it's gonna scan the first 1000 port as default, but you can always change that, and I'll show you the switch to do this. Alright, so our scan has ended, and as you can see, we have SSH22 open, 25 port TCP. Now the service that the Nmap is telling us here is SSH, meaning the default service that's running on port 22 is SSH, but it cannot be the case. So Nmap is just making a guess, right? Okay, we have open, and it's marking the port as open, meaning that Nmap has received a SYNAC packet from the service, and we can actually view this. So if you want to see why the Nmap actually has marked this port as being open, you can use the -- reason to view this. And let's not actually scan the entire 1000 ports, so because as you see it took a few times. So with the -p, the lowercase p, you can scan for example one port. I can scan for 80 as a HTTP or 22 SSH. I can also, if you don't remember the port of the service, you can give it even the name. I can see SSH, and you can give it multiple ports. For example, I can give it 80 443, and you can separate them by comma. If you want to give it a range, for example, I can see from port 3 to port 56. You can 56. You can separate them by a dash. And you can also omit the first option and use 333, meaning you have -33, meaning it's going to start from the first port up to 33. Or you can do the opposite, for example 78 dash, meaning it's going to start from the 78 up to the last port, which is 65,535. If you want to scan the all ports, you can just put a dash, which can start from the first port up to the last port. Alright, so in our example, let's just do the port 22, and we use the dash dash reason to show why Nmap has marked such a port as being open. So let's just say press enter and wait for the scan to complete. And as you see, it was quick because we're scanning only one port. And as you see, port is 22 TCP, its state is open, service is SSH, and the reason why Nmap has marked the port as being open is because it received a SYNAC from the service. Alright, so let's actually see if there is, let's see the let's scan a port that we know that it's closed. For example, we know 22. Let's see if the port 20 is open. Alright, so it marked the port as being filtered because Nmap hasn't got any response, and the reason why is because no response. Nmap has waited for a response, it didn't get one, and marked the port as being filtered. Let's scan for a port, for example, that we know it could be closed, 7890, just any port. It's also filtered and no port. Probably that's because there is a firewall. Let me scan my own router. So Nmap-st, we're using the TCP Connect Scan, and my home router IP address is 192.168.1.1. And let's also use the reason to show us why it thinks such port is closed or open or filtered. And we scan for port, let's see, port 80, just port 80. Alright, so the port is open, it's run service HTTP, and the reason why it marks the port as being open is because it received a SYNAC TCP packet from the target, which is our router in this case. Let's scan for a port that I know it's closed on my router, for example 445. Okay, so those scans can take a few time. You marked the port as being filtered, again just because of the firewall. Firewall can drop sometimes the packets and just not respond with anything, so Nmap just marks the port as being filtered because it didn't get any response. Alright guys, so I think that would do it for this video. Just to recap what we have talked about in this video, we have talked about the Nmap and using Nmap as a port scanner. We've seen the TCP Connect Scan and the three-way handshake. We've seen when scanning using the TCP Connect Scan, there are three states for the port. It could be either open, closed, or filtered. Nmap marks the port as being open when it received a TCP SYNAC from the service, marked the port as being closed when it received an RST TCP packet from the server, and from the server, the target machine service, and it marks the port as being filtered when it didn't get any response from the target machine we are scanning. Alright, so that's gonna do it for this video. I hope you have learned something from this video. If you did, don't forget to subscribe, hit the like button. You got any questions, comments, and anything, feel free to drop them down below, and I'll be happy to answer all of your questions. And wish you a good day, and thanks for watching.